All right, time for just a quick little scribblecast on applications involving powers and roots. And this is one you've probably seen in other math classes before. But specifically what we want to do is look at some problems involving the Pythagorean Theorem and powers and roots. I'm just going to give you two examples, I guess, of using Pythagoras to solve some questions. As you probably know, the Pythagoras theorem states that if I have a right triangle, in other words, a triangle that has a 90-degree angle in it, that if I take this side and square it, and this side and square it, and add those together, the sum of those two will be equal to the other side squared. That's Pythagoras. So, in a question, if I know two of those, I could figure out the third one. And let's try that. Contractor wants to prepare a perfectly right angle corner in a room. So here he goes. He wants to get a perfect right angle right there. So he measures out 6 feet along one wall, and then he measures 8 feet out along the other wall. So the question is, what does this distance have to be from the point where he marked 6 and the point where he marked 8? What does this distance here have to be? So when I look at the Pythagoras, I see that a squared plus b squared is equal to c squared. In this case, c is the hypotenuse, or it's the side opposite the right angle. So this is the hypotenuse, and that's what I don't know. So c squared is equal to a squared, a is 6, so 6 squared is 36, plus b squared, b is 8, so 8 squared is 64. So 36 plus 64 is 100, is equal to c squared. Now, to solve this, I want to get rid of the square. So I'm going to take each side and I'll find the square root of each side. The square root of c squared, of course, is c. The square root of 100 is 10. So there's an example where I've got some radicals. I guess I'm using the principle of powers there to solve that question, but I'm coming out to 10. And this is indeed some old carpenters, that's what they would do. To get a square corner, they'd measure 6 feet out from the corner on this wall, 8 feet out on this wall, and then they'd move these two walls such that the distance between those 2 points was 10. If they got 10, they knew they had a perfectly square corner. Okay, another example using Pythagoras is in this question. The length and the width of a rectangle are given by consecutive integers. Oh, how am I going to get that? Okay, rectangle. Length and width are given by consecutive integers. So I guess if I call this one W, this one, if it's a consecutive integer, it has to be one more than that. So this one would have to be W plus 1. Then they say the area of a rectangle is 90 square centimeters. And what they want to know is they want to find the length of a diagonal, and they want to find the length and the width. Oh, well, they give me the area. I know the area of a rectangle is length times width. We've seen that before. And if the area is 90, and if the length is actually W plus 1, and the width is W, here I've got an equation that I could solve. 90 is equal to W squared plus W. So if I rewrite this, I can write it as 0 is equal to W squared plus W minus 90. Notice I brought the 90 over there. It's a quadratic. Get them all on the same side. Then we'll use the 0 property. So 0 is equal to, let's see, I need to factor this. Two things that multiply to 90 that have a difference of 1. Got to be 9 and 10. So W here, W there, 9 here, a 10 there. Since this is positive, the larger one has to be positive. Okay, using the zero product rule says that W minus 9 is equal to 0, or W plus 10 is equal to 0. In this case, W is 9, In this case, w is -10. Negative number doesn't make sense for a width. I'm going with 9. So therefore, in my triangle, I have the width is 9, and the length is one more than that, or 10. One of the questions in there, they say find the length and width. Got it. But they also say what's a diagonal of the rectangle. So if I have a diagonal that goes across like this, they want to know what that length is. Well, if I know that the width is 9 and the length is 10, it looks to me like I have a right angle here. And right in here, I've got a right triangle. So now I could use Pythagoras to solve that. A squared plus b squared is equal to c squared. The diagonal is my hypotenuse because it's opposite that right angle. So this is my c, so I don't know what that is. And I know what a is. We'll call that one 9 squared plus 10 squared. So 9 squared is 81, 10 squared is 100. So 181 is equal to c squared. I'll square root both sides. And whatever the square root of 181 is, let me guess. 17, 16. It's around 16 or 17, I think. 16 to 17 in that range. Again, I should have my calculator. You can figure that on your calculator. All right, so those are some applications that involve powers and roots, specifically looking at Pythagoras to help us solve some applications. Try some questions.